We are almost through the course. Hopefully, working through this problem will help you see how things do fit together. So we're going to talk about why does sodium chloride dissolve and why does silver chloride not dissolve? Why is there a KSP for the silver chloride but not for the sodium chloride? Well, we can use the information in this chapter to show you why, all right? We can calculate a delta G0 and we try to find out why are the delta G0 so different. And then we can also take a look at how will that change with temperature and what does this imply. So here we have it. I can calculate the delta G0 at 298 for sodium chloride and silver chloride. For sodium chloride, my delta G0 turns out to be a negative 9.1. For silver chloride, my delta G0 turns out to be 55.6. So what does that really tell us? Well, note the sign. Here it's a negative, here it's a positive. It tells us the solubility of sodium chloride is spontaneous in the forward direction, and it tells us the solubility of silver chloride is not spontaneous in the forward direction. So that's just using the delta G value. But now you can take a look at what's behind the delta G. In this table, we have both the delta H as well as the delta S, because remember, delta G is delta H minus T delta S. Yeah, I could put the little zeros on there, okay? So let's look at the delta H of solution and the delta S of solution. When I look at the values for the entropy, they are very similar. Like they're in the same ballpark. They're both positive. They're like 10 joules, only 10 joules apart. So in terms of hydration, it's going to be very similar in terms of forming the randomness. Where you really see the difference is in our delta H of solution, a factor of, well, 10 plus, more than 10, all right? The enthalpy is very different. So that difference in delta G0 of solution, it's dominated by the difference in delta H0 of solution. Think back to that energy level diagram of chapter 13. The energy of hydration is much smaller for silver chloride versus sodium chloride. But we can go still a little bit further. We can actually calculate a K using the things we learned in this chapter. We learned that K is e to the minus delta G0 over RT. Let's choose room temperature and let's see if it's consistent with observations. When I plug and chug my numbers for sodium chloride, I get a KSP of 40. Well, that's definitely greater than 1. But more significant, what happens when I calculate my KSP for silver chloride? It's on the order of 10 to the minus 10. So in chapter 15, you learned how the magnitude of the equilibrium constant tells you how much reactants and products are present at equilibrium. Since K for sodium chloride is 40, it's primarily products. It is going to dissolve in water. But silver chloride has a K of 10 to the minus 10. It's going to be primarily reactants, and we will consider it insoluble. What's the take-home message for this? Well, will delta G0 change with temperature? Since both delta S0 and delta H0 are positive, we can plug in our numbers and we can see that an increase in temperature will make delta G0 more negative. The driving force for dissolution will increase with increasing temperature. Well, this is just a simple comparison of two solids. And I want to point out, whatever your profession is, you are never going to be asked to solve this kind of problem. Unless you're sitting in my shoes where I am now as a teacher. When I was in industry, very different situation. But you can use all those thought processes, all the time you put, all the frustration, maybe some tears, that you learned in this course to become what I would call a valued employee. As someone who used to recruit bachelor's, master's, and PhDs, you do need to have a strong technical foundation. But just as important is who you are as a person. When I would sit across the desk from someone talking to them whether or not I should bring them in for a job, it was who they were as a person that also made a huge difference. And looking at my former students, looking at where they've gone, if you have a dream, please don't give up on it. Open the doors, keep them open, learn this material. Because like I said, it's the thought processes that you're going to take with you. That said, we have finished chapter 19.